This demonstration presents Grouplanner, a group recommender system for tourism prototype. Grouplanner is intended to help occasional groups of tourists choose which points of interest to visit at a certain destination based on their profile, using their personality to solve the cold start problem. Based on our previous work, each user's tourist attractions preference is predicted by his scores in the 5 dimensions of personality. In the prediction, each tourist obtains a preference score for each tourism category, which is then used to categorize the tourist into a certain cluster. The clusters are used to divide the main group into subgroups of tourists with similar preferences, minimizing groups' heterogeneity and conflicting preferences. Due to the complexity associated to groups of tourists, several strategies are being proposed to improve recommendations, like using multi-agent systems. The remarkable similarity between multi-agent systems and microservices make them the perfect combination. This work demonstrates the implementation and improvement of a multi-agent microservice in a group recommender system for tourism, where each tourist is represented by an agent modeled with their profile and exposed as a RESTful resource, simplifying and making the client-agent interaction more efficient, aiming to provide faster and more personalized recommendations. Grouplanner is based on a microservices architecture implemented using .NET, composed of 5 microservices published in Microsoft Azure server: the user management microservice, responsible for managing the user's data; the social network microservice, responsible for persisting all the groups and subgroups data; the points of interest microservice, which retrieves and updates the point information using the TripAdvisor API; the recommendation engine microservice is responsible for assigning the best matching point to the recommendations request, according to the points of interest retrieved by the point microservice. The multi-agent microservice was developed using the AAMAS multi-agent framework and C#. When a tourist registers in the application, she needs to fill mandatory information related to her demography, physical limitations, and fears or phobias. To receive automatic recommendations of points of interest, the tourist needs to fill the Big 5 inventory to measure her personality, which is then used by the multi-agent microservice to predict her preference in the proposed 11 categories of tourism. The scores obtained can then be consulted in the user's profile. The application allows to save the visited points of interest, rate them, and define if they are to be revisited. After filling in the mandatory information, her profile is sent in a JSON via HTTPS post to the multi-agent microservice, which creates in the MAMS environment an agent model with a profile. After creating her agent, her similarity to 3 most preferred tourism categories of the tourist in the center of the existing clusters is calculated. If her tourist preferences are more similar to a certain cluster, she is added to that cluster. If not, a new cluster is created based on her preferences. In this case, Guinevere was added to cluster C2 after the calculations. When a tourist creates an excursion group, becomes the group owner, and a JSON containing group's data is sent via HTTPS posts to the multi-agent microservice, which then creates a travel agent representing the group. When a group owner requests a group recommendation, an HTTPS request is sent to the group's travel agent. If at least 3 agents belong to the same cluster, a subgroup with the agents belonging to that cluster is created, as well as a subgroup agent responsible for the subgroup members' communication. This process is repeated at the same time for the remaining tourists in the main group. Each subgroup agent then asks the subgroup's cluster members for their travel history and searches for positive and negative rules in the respective cluster using a decision tree algorithm. The rules found are added to a list of rules for each cluster, which will help in the recommendation process. If 50% or more tourists in a subgroup match a certain rule for a POI, that POI is added to a POI's exclusion or inclusion list, depending if it is a negative or positive rule. To help refine the recommendation list, a process of collaborative filtering is applied by the subgroup's agents to the ratings given to the visited POI. Negative rated POI and positive rated but that majority does not want to visit again are added to the subgroup's exclusion list. The positively rated are added to the inclusion list. For all the other POI with ratings in the corresponding cluster not rated by the subgroup's members, the average rating is calculated and added to the lists. After creating the subgroups, the travel agent sends a JSON with via HTTPS post to the recommendation engine microservice, containing the subgroup's information and their POI exclusion and inclusion lists. The recommendation engine then searches for the best matching POI for each subgroup in a POI ontology, persisted in a repository with POI retrieved from the TripAdvisor API, considering the POI's inclusion and exclusion lists. After determining the best matching POI, the recommendation engine answers to the requesting travel agent with a JSON containing the list of POI suggested for each subgroup. The travel agent then sends the JSONs to the Grouplanner application, which creates the suggested subgroups and presents them on each subgroup's interface along with their respective POI recommendation lists. At this point, each subgroup's member can obtain more information on the suggested POI and rate them. The group owner is responsible for asking the subgroups if they want to keep their recommendations or ask for new ones. And that's it. Thank you for watching.